Hello everyone, welcome back to this Siemens S120 PLC and S120 Servo Drive series video. In this video, I would like to discuss how can we program the motion control function block and the motion control program. And basically, I would briefly introduce two methods. In my channel at motion control playlist, actually I introduced how can we use the TO and the motion control function block. For example, MC reset, power, home, jog, move absolute, move relative, and move velocity to control the servo drive. By that time, when I introduced how to program those function blocks, I used the virtual access. That time, I didn't have the servo drive. Fortunately, I got a chance to have this real motion control demo. So I'm able to replace the virtual access to this real access. This is real motor and a real encoder. But when we use the MC function blocks to control the servo drive, we will see one issue here. To control one servo drive to one axis, basically we would program 10 function blocks. MC home, MC jog, MC absolute, those function blocks. Then in your system, if you have a 10 axis need to control, that means probably you have a 100 function blocks need to program. Those are really huge job behind. That's why in this video, I won't introduce basic MC programming. I would directly introduce two efficient ways. One way, you can directly go to the Siemens support website and then find out this ID, 110.97.49.348. In this example, you will find two typical function blocks library. One is the basic library. It also have a HMI. One is the advanced. And from this table, you will see the basic library and advanced library, what the difference between them. Basically, if you are going to control the servo drive for the positioning control, the basic library, that's enough. In case you need to control the gearing or some higher end motion control, probably you can use the control library. For most of the cases, I like this basic library. Another way, once you program those MC function blocks, we could gather all those MC function blocks into one function block and use multiple instant DB into one FB. In this video, I call that FB100. Inside this FB100, I have the MC power, MC home, jog, or move absolute. I can customize by myself. So this is basically two ways. One way come from the Siemens support website. One way you can program by yourself and follow your flavor. All right, please follow me. I will briefly show how can we build up this FB100, build up your own function block for motion control. In the previous videos, I introduced how can we use TO and how can we use the MC function blocks. We did a quick test, use MC reset, MC power, MC jog, and MC velocity. Those four typical function blocks, so we can run the access, do a very quickly test. And from my drive, I'm using S120, this drive system. So in this case, I have the blue and the red, two axes here. And from the TO, I have the red motor and the blue motor, okay? And for each motor, basically, we need reset, power, jog for manually control, and move velocity. Probably you also need to use the positioning control, right? So you can imagine for each axis, you need to do the similar job like this. So it will be nice, we create another function block. That function block includes those multiple instances. So every function block includes the typical MC function blocks like reset, power, move jog, and move velocity and move position. Okay, this is my big template FB100. So inside this template, we can see it won't be difficult. So it also has this typical MC reset. So here, this is some condition we can enable MC power. So as we can see, MC power here, this is access ready. Okay, so this could be some logic here. For example, the drive communication, the drive in operation, the encoder communication is working, and the sensor in a proper condition here. Okay, and this is the MC power. And then MC home, so we can zero the position value. And MC jog, this basically can be used for the manual control. Okay, and MC velocity. Okay, here we can set the velocity value. And MC relative move, this is the axis. So the axis here, the axis come from this in and out. Okay, and this date type for the 1500 PLC, that's this. MC absolute. To stop the axis, we have a MC hot. The regular stop by application, so we can use MC hot. And to immediately stop the axis, we can use the MC stop. Okay. And here we can also monitor the speed, velocity, and the position. Also transfer the standard still status. Okay. And this is the error signal. Those errors summarize all the function blocks error. For example, the function blocks error here. Okay. And to quickly review the input and output, we can see here, for the input, we have the bool signal to enable or trigger the function blocks, or we can set the velocity and the positioning command. And this is the output status. Okay, and we are using multiple instances here. Okay. And then from the outside, when we call this function block, we need the variable to connect the input and output. I'm using this DB. Inside this DB, I am using this date type. If you have a multiple motors, you can create multiple motors. Okay. This DB is used here. And this date type, I'm using this date type here, the UDT access TO. So this is my date type in this TO. You can customize the numbers of those variables or rename to other names associated with your project application. Okay, so now I'm going to use this project as my library or as my base. And I will still use my S120, that test program, and I will copy those programs into my S120 project. Okay? And then I will leave this window at here. The left side project, that's the S120 project we used in this series video. We did step by step and we did the commissioning before. And the right side is my library template. And before I copy, I will firstly reorganize here the project. So I will create a new group. Okay. I will go safety program. So let's drag all the safety program to this folder. And those are the test program before. So I can name, I won't delete that so far. I just throw to this folder. Okay. And then we can create another folder named motion control. Red and blue. Okay. I will copy the function block under this folder here. Okay. And before that, I will copy this date type. Okay, copy this UDT date type. Copy to here, date type. Okay, copy to here. And then copy the DB, the date block. So DB. Okay. and I will copy under here. So if we open inside this DB is using this data type, we just copied at here. And here the motor, we can name the red motor and rename this to blue motor. Okay. Okay, this is the DB. And now I'm going to copy the function position and it's instant here. Copy and paste it here. Okay, and this is my function block template IB100. And when we call this IB100, the instant IB positioning axis. So this is, we can call the axis red, and another one that's the blue. So we can copy and paste, and we can create this the blue. Okay, and rename this blue as 102. And this is the instant DB. So the MB function block, that's this instant of positioning axis IB100. Okay, now go back to the OB1. We will use this IB100 to control the axis. In my right side, the sample project here, OB1. Okay, I will copy this network, paste here. All right, and for the right axis, I will drag this DB101 to here. This is the instant DB of this axis. Okay, red motor. Okay, and then I will copy this network 2 to network 3. So this network, I will name this the blue motor axis, and then drag this blue instant DB to here. Okay, and for the input and output here, for the red, the input here, if we open this DB block, so this was named M1, right? So this axis MC reset, that's this. So actually we need to rename this M1 to red. Okay, so we can change and replace. So we can click this Control F, so search here. Okay, and now we can change this M1 dot to red dot. Okay, so from here we can click this replace, 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 replace. And then this axis 1, this is the axis TO. So for this red motor, we will drag this TO here, this red motor to here. Represent this function block will control this TO. Now temporarily it shows a red. It doesn't accept this, but doesn't matter. So let's double click this function block and let's jump in. There's something haven't updated yet. Let's double click this FB100. After all, we copied from my template project into this project. So inside that function block, a lot of FC function block need to update. So let's right click, click this update. So we can update. So we can find this here. We can update the interface. Okay, so we click the update. So they all got an update. Now let's go back here. For the red motor here, we right click, click this update. Then we'll see the TO we dragged here that accepted. Okay, we got updated. We just did the red motor, and now let's do the second FB function block. So second one, this is blue. Let's change the interface name to blue. So we can open this DB, this variable DB. and here the MC reset, here we can drag to here. Okay, so this is the command. So which means we will rename this M1 to blue. Okay, so I can close this, and from this line network 3 here, we will change the name to blue. Okay, replace. Okay, we change done. So let's update this function block, and then for this axis TO, we will drag the blue axis, this blue motor, and drag to here. Okay, and if we shrink, we can see no error fault. This is the axis TO. After we download, once we power on, we can see this function block can control the motor. Alright, after we download the program, and now I'm active this online monitor. So far, the CPU and the drive, they all happy. So we can see the CPU, there's no any error. And from the drive also totally good. The drive also happy here. And now I'm going to use the MC function block to control the right motor. Okay, now I go to the OB1. Okay, click this go online. And now I'm going to reset the right motor first. Okay, to reset any fault if possible. And now I'm going to turn on this MC power. Okay, we power on the motor, and I'm going to use the jog forward to verify if this forward direction match our actual position, match our actual direction. So forward jog. So we can see this output velocity is moving, and actual position is also increasing here. So this is a jog forward, stop, and after we stop, we can see this stand still turn on, and jog reverse. Okay, go reversing, so that's why the velocity, that's the minus. Okay, if I release this input, the motor will stop. This is a jog. Usually we can use the HMI, use the momentary button to control this motor, the jog moving. Okay, now I can use this MC home to home the axis. And in this function block, the MC home, I'm using very simple way. So I'm using the 0.0 set directly 0 to the axis, and mode, that's the 0. This is the direct set the value to the axis. You can check the MC home, the detailed explanation for different MC home mode. Okay, and here I will trigger, and in the meantime you can watch this actual position. And now I'm going to trigger, boom, right 0 to the axis. Okay, and now I can use the velocity to drive the motor. Okay, and before that we need to set the MC velocity target. I set minus 360, that means we will drive to the reverse direction. 360 degree per second, unit is degree per second. That's why the motor will drive towards to the reverse direction and 1 revolution per second. And now once I trigger, so we can see this actual velocity, that's the minus 360. It runs 1 revolution per second towards to the reverse direction. Okay, if I'm going to stop this axis, I have to use the MC hot or MC stop. Okay, hot is a gentle stop. Okay, I trigger, we'll see the motor gently stop. And now if I change this target to a higher speed, for example 720 positive value, and once we trigger, so the motor will run the forward direction 2 revolutions per second. trigger. Okay, it's running faster. Okay, and this time if I trigger this MC stop, we will see it will stop very fast. Stop, boom, we can see it stopped quickly. And if I leave this true, the motor won't move. If I trigger again, we can see the motor won't move because, and in the meantime, the arrow will turn on because this MC stop is holding this, locking this axis. Okay, so turn off, and the arrow is still here. We need to click this reset to reset the arrow. Okay, and now I will home the axis again. Let's try the relative move and the absolute move. Home the axis, and in the meantime watch this actual position. Trigger, right 0. And now I will set the relative position move, relative distance. Let's set 1000. Okay, and MC relative move, trigger.
We will try 1000 degree the distance.
So it drive to the 1000. For the relative move, if I trigger the relative move again, so it will travel another 1000. Trigger again, it will drive to 3000. Okay, this is the relative move. If I set minus 2000, it will drive to the reverse direction. Every time it travel 2000 minus reverse direction. Okay, if I trigger the MC relative trigger, okay, we can see it drive to the 1000. Let's drive another 2000 minus. Okay, it go to the minus 1000. Okay, this is MC relative move. And now let's try the MC absolute. Okay, I will set this relative to 0. Now this MC absolute position, let's drive to 2000. 2000. And then let's trigger this execute MC absolute, and meantime watch this output. Drive. Okay, we can see it has acceleration and deceleration. Okay, it drive to 2000 because this is an absolute position move, and if I trigger again, the motor won't move because it arrived this target. If the target won't change, even if you trigger it again, it won't move. Okay, it stopped here. It shows standstill on. Okay, and now if I set minus 2000, it will drive to the negative direction. Minus 2000 target and this MC absolute trigger. Okay, it drive to the minus. If I trigger again, it won't move. Okay, it won't move. Okay, this is the basic idea to use the MC function block to control this axis. So as we can see, we can jog, we can velocity control and the positioning control the axis using this function block. Okay, and to disable the power, we can turn off the power. Okay, we turn off the power. And when the power turn off, if we jump into this axis and watch this standstill signal, shrink and turn on, and make sure we are monitoring the red motor, so we can see this status still on. even the power off. The standstill represents the actual status. Okay. Okay, this is the red motor. We will do the same thing for the blue motor. Let's go down. And this is the blue motor. So this instant dB, that's the dB102. And again, same thing. We will reset first and power on the blue motor. Power on. And I will try to jog forward and backward, verify the direction. Okay, this is the positive direction. And let's do the negative direction. Reverse. Okay, reverse. And now let me set the MC velocity, this trigger, what the speed we can travel. Okay, I set 720. Okay, and let's travel MC velocity, trigger, in time output speed, in time output velocity, 720. Okay, it's keeping driving. To stop the access, we can trigger this halt or stop. Okay, trigger halt.
It ramp down and stop.
Okay. Alright, this is the video to show how can we use this function block. Basically come from my style. So inside this function block, if we jump in, and since this is a function block to online monitor to troubleshoot in case, you can click this button. You can switch the multiple instant dB. For the red motor, you can click, and now all the signal represent the red motor. So you can see the red, blue. So now all the signal here that shows for red motor. If you want to monitor the blue motor signal, if you click OK, so all the signal here represent the blue motor. Okay, and we can see the reset here. This is the axis. So using this in and out here, it will transfer this TO dB to here, and execute. That's the input. This is the input of this function block. Okay, and access ready here. So this is the access ready signal. We can see if everything shows okay, it should go through this line. And MC power, if the motor is power, so the status will show true. Okay, so this is the MC function blocks. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.